Welcome everybody to our coffee break in our EWI series, Analog Cinematography in the Digital Age, working with film and film cameras in 2024, hosted by our friends at ARRI. We always need to thank our annual sponsors, without whom none of this would be possible at all. We have Anton Bauer, ARRI, Astera, Duclos Lenses, Lightgear, Panavision, and Taylor & Taylor. We are talking with Mike Sippel, who is a friend at ARRI and works every day with these film cameras. So, Mike, please take it away.
All right. Hello, everyone. Welcome. Thanks for coming. Let me get my PowerPoint up here. As Allison said, I'm Mike Sippel. My title is Senior Engineer. I've been working with film stuff for 20 odd years now. I've been with ARRI for 8. When they asked me to do this presentation, I wasn't quite sure what level of technical specificity to get into. So if at any point I get into the weeds a little bit and you guys are and I'm losing you, let me know and I'll try to bring it back a little bit. I always try to err on the side of presenting more information than perhaps is necessary, figuring that people can always bring it back if I need to. Start out though with just a brief survey of the audience here. How many of you are currently working at rental houses that already have film cameras? Is there any way to do a show of hands in here? I'm more of a Teams guy than a Zoom guy. One says no film anymore, but that's what I learned out. Okay. All right. I guess I'll just go ahead then and let me know if it gets too technical. I guess the first question, why would anyone want to shoot film now? A fair question, since digital is obviously the default for most people at this point in time. Just this past weekend, we had a marvelous new digital camera coming out, and we're telling all people about why it's great to shoot digital. Now we'll be flipping back to why it's good to shoot film. Fortunately, we're positioned in such a place that ARRI supports film still to the extent that we can, and there are still people out there that want to use it. But why is that? A lot of it has to do with the look. There are certain things about film that you can get with an analog process that you can't get still with digital. People have found a lot of ways to fake it to varying degrees of success, but there are still, particularly the granularity of film and the way that essentially you have a new sensor every single frame when you're shooting film is not something that is replicatable with digital. The city mechanics do. Yes, and yes at Expressway. Excellent. That has a nice sort of dithering effect for those of you familiar with who have worked in audio before or digital signal processing. The idea of dithering, sometimes just by adding noise to a signal, you can actually, particularly a quantized signal, you can kind of smooth out some of the transients and actually get a better result than if you just strictly quantized it as precisely as possible. The randomness of the granularity of the actual silver halide crystals in film gives it that sort of softening effect, has a very pleasing and cosmetic effect on people. So some cinematographers like that. Also, one thing that people have not yet really found a way to do the same on digital is to create the sense of heat that film can. A lot of that comes from the way that film handles highlights. If you look at this particular image and sort of you look at the sun, dappled sun reflection on the water there, you see how around each light patch there's sort of a glow to it, a little bit of a reddish glow. That actually has to do with the physical structure of the film, essentially the failure of the anti-halation backing. Don't worry about what that is for now, but it's part of the film. When that is defeated by a very strong highlight in the frame, you get that sort of glow effect, which is very difficult to replicate in film in in organic fashion. And that has been used historically to great effect to connote a sense of heat. It's also possible, or digital has gotten better, certainly over the past few years about this. One thing it has historically not been very good at doing is very saturated, but not bright colors. And that has to do with the way that film represents color via a subtractive process versus digital, which is inherently an additive process. With film, you are starting with white light and adding layers of filtration to it essentially to cut out the wavelengths you don't want. So you can have a very saturated color without it necessarily getting very, very bright. Obviously, in this particular case, we are communicating over a digital medium, so we are stuck in an additive color process. So I can't really show you the effects of what I'm talking about here. But in the case of any digital color process, you are adding up red, green, and blue channels, three different light sources to make white, or any color along the way, as opposed to cutting down, starting with white. The net result of that is to get more saturation on a digital process, you often have to add higher signal level, which can result in sort of unnatural or those sort of nuclear looking colors that you will sometimes see, particularly on less subtle digital cameras, let's say. And finally, sometimes you just want something weird and whacked out. And in because of its analog nature, in film, in many cases, it's easier to achieve this than with digital, just because, especially if you are not a computer programmer, with digital, you're often sort of at the mercy of what tools other people have created for you in terms of how to manipulate images and what sort of plugins or manipulations people have developed. In the case of film, it's an analog medium. You can get all sorts of interesting effects out of it by doing stuff to physically mess it up. Back in the 90s, it was some music video directors famously would take their negative after it was shot and put it in the oven for a few hours before they'd process it. There was various forms of homemade processing. There's some sort of niche movements online of people that make their own film developer and make films with their developer that they make from things like coffee grounds. There's somebody that's done it with, I think, dandelions. There's a lot of sort of off the wall chemistry that you can use to develop film. It's not going to give you anything approaching what Kodak would regard as the technically correct result, or even predictable result. But just because it's not technically correct or predictable doesn't mean that it might not look cool. So that's sometimes, and that's something that people, you can literally mess around with it in your sink if you've got a dark room. So that's one thing that film can do that digital absolutely cannot. Just that sort of inherent analog nature of it, much more accessible for manipulation versus digital files. There's also importantly, and this is a thing I've learned largely in conjunction, I've been giving these talks for a few years now in conjunction with Kodak. One thing that I have encountered in talking to cinematographers as we talk about this process, it is sort of a psychological effect. Sets that are film sets run a bit differently than digital sets. It's whether it's because ultimately the cost of the recording media is a small pip in the overall budget of a major motion picture, but at the same time, when that film camera is turning over and you know that that is a substantial sum of money that is just flowing through the camera every single second, there is a sort of urgency to that. There's also the fact that film sort of forces you to have at most, a discipline to it, because you cannot get more than, I guess Panavision has some 2,000-foot magazines, which will get you 22 minutes per load. But with all ARRI film cameras, you are capped at essentially 11 minutes with a 1,000-foot magazine at 35 millimeter before you have to reload. And so it enforces a cadence to the production. You can't just let it roll and keep going, which I've heard stories about boom ops, getting tired as takes go on into forever, or directors just say, well, we're going to do another take, but we're just going to keep rolling. People need time to reset. People need time to recenter themselves, technicians as well as actors. And I think sort of sometimes that is lost with the tendency to just want to keep rolling in digital. One thing for cinematographers in particular that film connotes a benefit, it adds a certain degree of more authority and mystique to the position of the cinematographer, on the basis of the fact that with film, you can't see what you've got until it's processed. You don't know what you have on set. And I think that there has been, and it has been said to me, I'm not a cinematographer myself, but it has been said to me by others that the presence of having a large, high quality video assist on set now in the form of you can see something that even if it isn't the final picture, looks close to the final picture. Suddenly, everyone feels very qualified to make judgments about what that picture looks like on the basis of the fact they can see it, irrespective of their actual training and their knowledge of the overall process and what is going to happen to the shot after it leaves the set. Um, it sort of it makes people think they know more than they necessarily do, and that can make the cinematographer's job more difficult in some cases because a lot more of their job becomes more about managing expectations than just doing cinematography versus with film, because no one sees it until it's actually processed, you have to sort of trust the cinematographer. It's not a useful analogy in my mind is like when you're building a building, there's a reason why you hire an architect. You are obviously there's pre-visualization and other things, and you make models so you know what it's have an idea of what it's going to look like when it's done. But you are trusting the architect to make sure that the building is going to stand when you build it before you build it. Because if you build it and it doesn't work, it's going to be very costly. So, in a similar fashion, when you're shooting film, there's sort of an inherent trust placed in the cinematographer to know that, yes, this is going to work, or no, this is not going to work, and make sure that what you're doing is going to result in a usable image. So that's some of the politics of why film is popular now. Also, just some people learned on it, and that's what they are used to. And as those people age out of the workforce, that may change, but there is actually growing interest among younger emerging filmmakers also to embrace this medium and keep it going, which is good because the surest way to keep it alive is by people using it in a commercial sense. By its very nature, it's not something that can be done at small scale. Kodak's plant is quite large, and it's built to scale. They can only keep it running if it has a certain degree of volume going on a per year basis, which they're back now to, I believe, 3 shifts of production 5 days a week. For a while there, they had gone down from that. So it has come back substantially from sort of its low point, probably around the early 2010s when digital was really sort of the only thing that was being used. So, yes.
So I just sent it to Amanda.
Will you
Well,
send it to me?
Sorry. Oh, okay. Somebody. Oh, there we go. Muted. Thank you. Please, yeah. If you do have questions, please feel free to speak up at any time. But yeah, try to avoid any background noise if we can. So.
Bye-bye.
A brief explanation of how exactly film works for those of you who don't know, and this is again fairly technical in the weeds. So let me know if I'm boring you or if this is not necessary. But I personally get tickled by this stuff. It's interesting to me how a fundamental physical process like this was exploited in a fairly clever way to make pictures. So this image here you can see is actually a scanning electron microscope picture of film grains inside of the emulsion that goes onto film. As you can see, they are of different shapes and sizes, and we will explain that why in a second. So how does film work? The basis of it is the silver halide crystal. It is a molecule made up, or a substance made up of molecules made up of a combination of silver and a halide, which are one of those elements on the right side of the periodic table, like your bromine, iodine, chlorine, all those things that end in INE, so-called halides because they form salts when combined with metals and metalloids. So silver halide crystal, basically silver salt. It has the unique property that these silver and halide atoms are very loosely coupled, so that when a photon strikes it, the energy of a photon, a quantum of light, is enough to knock an electron loose from the halide and surrender it over to the silver. This breaks the bond between the silver and the halide, and the silver sort of floats off by itself, where it is free to stick to other silver. It will not re-stick itself to another halide atom for chemistry reasons, but silver will clump together with silver, forming an infinitesimally small speck of metallic silver. Critically, the silver halide crystal is translucent. It's cloudy, but it emits light through it. Metallic silver is not. It's silver metal. It blocks light. So every time a single photon hits one of those molecules, this can happen. You have that, multiply that by trillions of photons striking a surface over the course of an interval of time, you will have many such strikes and accumulate many such little infinitesimal specks of silver, which will naturally clump together for physics reasons, forming what they actually call a speck. That is the technical term for it, a speck inside the silver halide crystal. What's critical about that is the presence of metallic silver, similar to if you've ever done a science experiment where you saturate a solution of water with sugar by boiling it, and it's liquid until you drop a tiny crystal of sugar into it, and then the whole thing just freezes solid into a crystal right away. If you ever did that back in middle school or something. In a similar way, the presence of metallic silver in a silver halide crystal, when used in conjunction with the developer chemical that it's then put through after it's been exposed, the developer continues the process of converting the silver halide crystals into metallic silver, albeit at an exponentially faster rate than would happen if you were just doing it with light. But critically, that process is catalyzed by the presence of existing metallic silver in the silver halide crystal. So on a practical sense, what does that mean? The silver halide crystals that have been exposed to light, that do have metallic specks already in them, will be converted fully to opaque metallic silver much faster than those that do not, resulting in essentially a photograph. Those things that received more light will have a disproportionate number of silver halide crystals that have metallic specks. Those are the ones that turn dark when you process it, run it through the developer. Once that's done, so you put it through the developer, you expose it, you put it through the developer, that converts all of the silver halide crystals that already have exposure into metallic silver. Then you run it through a stop bath, which halts that process. Then you run it through another chemical called a fixer, which washes away all the unexposed silver halides that are still in a silver halide form, leaving behind just the metallic silver, which winds up looking something like this when you look at a cross section of a piece of film. All those little black specks you can see in there are grains made up of silver halide crystals that have been converted to metallic silver. That's how it works in black and white, and it has both for still and motion, the most simple incarnations of it early on. Color is done with an additional step. They use what they call dye couplers, which are a special class of chemicals that are themselves in their precursor state. When they are the dye coupler chemicals, they do not have a color to them, but they react with some of the byproducts of the development process of silver halide into silver to become a color. So essentially, when you have silver halides with a dye coupler attached to them, if the silver halide reacts to the developer, the dye coupler converts from the dye coupler into dye, and you're left with a blotch of color in addition to the developed silver halide crystal. You then use another chemical they call a bleach. It's not actually a bleach like you would buy at the grocery store, but it has that effect of washing away the silver halide crystals, leaving you just with the dye spots left behind. And now you've got an image separated in a stack like that with 3 different layers. If you remember back to your subtractive color theory from school, you got your yellow, magenta, and cyan. And then all of them together in perfect proportion form black, or a full color image, if not completely saturated. So that's how you get color. And this is, of course, the same process, whether it's a motion picture camera or a still camera. This is just how film works generally. In the case of a film camera, what are we doing? Well, we've got a magazine that holds the film, pulls it out. You have to pull the film out of the magazine through a mechanical system called the transport that encompasses all the sprockets, rollers, etc., inside the film camera that are actually physically transporting the film through as it's getting exposed. That moves it past the intermittent movement, which is sort of the heart of the whole operation of a film camera. That is the mechanism that converts the rotational motion of a hand crank or electric motor into the intermittent movement of advancing film by one frame, stopping it for a period of time, and then moving it again. Works kind of like a sewing machine. I'll get in that a little bit more detail on that later. But the movement is the part that holds that whole hold down claw, registration pin, intermittent movement part of it. Similar to if you're a watch fanatic, they'll talk about watch movements. Same thing. The ticking second hand of a watch uses a similar intermittent mechanism. The film is exposed. While the film is exposed, it's being slid past on a piece of metal, typically metal called the gate, into which there is a cutout called the aperture. The aperture defines the size of the window through which light is allowed to pass to expose the film. While the film is being pressed against the aperture, it's held in place by a pressure plate in most circumstances. Sometimes it's built into the magazine itself, but that is the goal of that is to keep the film pressed flat against the gate. In front of the gate, there is a shutter mechanism that is admitting light when the film is pressed up against the gate and ready for exposure, and then blocking light while the film is being advanced from one frame to the next. If you did not have a shutter, you would just have a streak. You can actually play with that effect a little bit, which I'm not going to get into this presentation, but one of the neat things that you can do with film is by intentionally throwing off the timing of the movement so the film starts to move before the shutter swings all the way closed, you can get some cool streaking effects. That is something that you can do with film that you cannot do with digital because it relies on the fact that film is actually physically transporting the imager past the gate. Then the film comes back through the rest of the transport mechanism and back into the magazine. This is a photo of an ARRI cam gate. You can see there you got the aperture, which is just a window. The aperture size depends upon the format, but also the number, in the case of 35 millimeter, the number of perforations you're having in your pull down. We'll get into that a little bit later. But you can see there's a couple of holes that two registration pins shoot into to hold the film solidly in place. They catch the perforations and sort of hold it there steady while it's being exposed. You have some channels for the pull down claws, which are little hooks that come into the film, grab it, and then advance it by one frame. That's part of the movement. And the gate must be kept extremely smooth and polished so it is not scratching the film as it flows past. At a more granular level, again, the operation of what's going on within a single exposure cycle with this diagram here, we've got in yellow here our aperture, film is the black, and the green is the registration pin, the red is the pull down claw, and you see the shutter there. So during your normal exposure cycle, you've got the film there retained by the registration pins, shutter is swinging around, that's your exposure interval, usually 1/48th of a second if you're using a 180-degree shutter at 24 frames per second. Once that's done, shutter swings along, the registration pins withdraw. Now the pull down claws enter and advance the film by one frame while the shutter is still completing the rest of its swing around. Registration pins go back in, and then the shutter swings back open, and we do our next exposure. So this whole process is repeating potentially hundreds of times a second in high-speed cameras, but it's just that same motion over and over and over again, stop, start, stop, start, stop, start. Film comes in lots of different sizes, gauges and formats. The gauge specifically refers to the size of the film itself versus the format refers to the size of the image, size and shape of the image that you are recording on the film. So in a given film gauge, there may be multiple formats. All of them have them actually. So in the 8mm form factor of the 8mm gauge of film, you can do 8mm or Super 8. They have two different sizes, and in that case, they actually do use slightly different types cuts of film for those two different formats. 16mm, while you can shoot normal 16 on Super 16mm film, the difference is the number of perforations. Conventional 16 has perforations on both sides. Super 16 only has them on one side. Otherwise, they are the same size of film. It's just two sets of perfs or one. 35mm film, the difference in formats, we're not going to get into too much between silent versus sound, but there's what they would call Academy aperture. There's super aperture, which is what is sort of standard now. There's also VistaVision, which is an increasingly rare bird. Always has kind of been. It's been more of a specialty format, but that passes the film through the camera horizontally as opposed to vertically, so you have a larger frame. Similar, it is the same size essentially as a 35mm still film frame, and that has historically been used for visual effects purposes where you need a larger image which allows you to have finer grain. So if you're going to be doing optical printing or compositing, you have more detail to work with. Then in the 65mm gauge, you have conventional 65mm 5-perf flowing through vertically through the camera, or 15-perf IMAX, which goes same film flowing through the camera horizontally. Big difference, particularly there, you can see in terms of the amount of area available for picture, depending upon the way that you're just transporting the film through the camera. That results in a substantial increase in image quality from a standpoint of having finer grain. So that's always been the goal. Film has gotten exponentially better since it's since its dawn about 100 years ago, in excess of 100 years at this point. But in the early days, film was very still grainy. It was very slow. It required a lot of light. And even if it was adequately exposed with a lot of light, it still came across as fairly grainy. So for the longest time, the emphasis was always on trying to find a lower grained image that would be sort of glossier and slicker. So larger film frames were the easiest way to do that, but that came at a cost. Namely that larger film costs more to produce, is heavier. You wind up using more of it on a per foot basis to shoot a motion picture, and all the costs add up. Critically, unlike a digital camera where you are seeing what's coming off of the sensor, in a film camera, you have no way of seeing what's actually going onto the film. And in most cases, you do not, at least in a modern reflex camera, you do not see what goes onto the film. You see 180 degrees the opposite of what's going onto the film. Allow me to explain. So you have what's called the viewing system, and that is the system of tubes, mirrors, prisms, etc., that direct the light coming in the lens up to your eye so that the camera operator can see what it is that they're shooting. Prior to the advent of what's called a reflex camera, where you're actually looking through the lens, the system was more akin to a rangefinder. So if any of you have ever shot stills with like a Leica or rangefinder, you have sort of one separate lens that you're looking through, and then it's using parallax and some adjustable little wire cages to show you what your actual frame is going to be, but you're not looking through the lens itself. Obviously, because that's an approximation, you don't really have a preview of the depth of field, and there's only so precise you can get in terms of the framing. Reflex offers the advantage of being able to look through the actual taking lens and see exactly what the film is going to see, with the caveat that you are actually seeing only what is passing through the lens when the shutter is closed and the film is being advanced. So you can only, and if you look through the viewfinder of a film camera when just turning over, the image is flickering because you're seeing the film shutter moving around in a circle there, blocking out, alternatingly blocking out the light, and then continuing to swing forward. You're only seeing the parts where the film is not seeing light. Film camera eyepieces have a shutter on them, which you can see here. That is important because unlike a digital system where you are looking at a display that emits light and is not a sensor, the viewing system of a film camera goes both ways. Light can go in, light can go out. And that is critical because if you do allow film or light through the eyepiece into the viewing system of a film camera, even when the shutter is closed, you can see the effects of that light get recorded on the film. Part of my own journey in getting involved with this process of educating people about how film cameras work was from an experience we had here at ARRI Rental, where an actually fairly well budgeted production, the cinematographer, I guess, had not worked with film before and did not realize that you have to keep your eye pressed up against the eyepiece all the time when you're running the camera, or else snap the shutter closed while you pull your eye away, or that the light will get in and spoil the shot. They didn't know that, and they had some shots spoiled by some overhead light from in a grocery store, and the light you could basically see the lights of the fluorescent lights passing overhead reflected into the film, and like bars going across. And they came back to us and said, well, there's a problem with your camera. And we said, respectfully, no, there's not. That's very clearly an image that was projected onto the film through the viewing system. And it became a whole big litigious thing, which led to the conclusion that, this is some fairly fundamental stuff that I think a lot of people out there that are now starting to use film may not necessarily know. And we sort of took it upon ourselves to sort of start spreading that information so more people can be educated about it. But yes, the eyepiece needs to either have your head against it or the shutter closed. In some cases now, if you are not going to be using the eyepiece, which you might not because of the viewing system, we'll get to that in a second, some camera assistants will just choose to put a sock over the eyepiece, so there's no chance of light getting in. Some of them will actually choose to remove the viewing system entirely, or at least the eyepiece portion of it, and then just block that with a cap. All of the light inside the viewing system is passing through a combination of, and you can see here at the very bottom there, I got a ground glass right above the shutter. Above that ground glass is a piece of glass called the field lens. What it does is not super important, but I have this slide here to call attention to another critical thing about film cameras that's not always apparent with digital cameras, and that is that you see all the dust. Obviously, dust on the sensor in a digital camera can be a problem, though you can get away with a lot. And I know that you can because I'm the one that cleans a lot of the sensors here when cameras come back from shows. And sometimes I get things back from a show and there's so much dirt on the sensor. I'm like, how did they not see that? But I guess if you're shooting wide open, you don't. But in the case of a film camera, proper maintenance and constant cleaning are actually a lot more important than they are on a digital camera. A digital camera, you have very few moving parts. Generally, you have some fans maybe, and you want to keep dust from accumulating inside the heat exchangers so it can continue to radiate heat. But aside from that, there isn't that many things that can go wrong mechanically. If dust gets into somewhere, obviously, if it gets into the optical chamber, that's different situation. But in the case of a film camera, because it is a physical medium, there's stuff physically being transported through it all the time, and it is an optical medium where you're looking through the optics. If you get dust into the viewing system, your operator will see it, and the operator will probably complain and ask for the viewing system to be cleaned. If you're working on a film camera as a prep tech at a camera rental facility, that's one of the steps that needs to be taken with a film camera that is not necessary on a digital camera, is just checking the viewing system to make sure it's clean before you hand it to the client, because they'll probably complain if it isn't. In a similar fashion, dust or dirt, the fact that you have film passing through the camera all the time, that film can itself shed flakes of emulsion. Dust can get inside the actual chamber that the film moves through. All of those things can get gummed up inside of the movement and cause it to seize up. It can cause registration problems. It can cause burnt out motors. Physical medium, got to keep it clean. A dirty film camera is a film camera that is possibly that will fail much more quickly than one that is kept clean. Film cameras have video assists. Thank you, Jerry Lewis, for that. Essentially, the bright idea of taking a video camera and bolting it onto the film camera so that people other than the operator can see what the operator is seeing. ARRI made this sort of the state of the art to this day are these what we call the HD IVS systems that were made for the 435, the ARRI Cam LT, and the ARRI Cam ST. These were HD cameras that were integrated fairly tightly with the camera, had a lot of onboard information in terms of it had a nice graphics overlay that would tell you frame rate and shutter angle and all that neat stuff that you see people are used to seeing in the heads-up display on an Alexa now. Previous to that, sort of the earlier incarnations of the video assist was literally just a little ice cube camera bolted onto the side, where there was a prism that would split the light coming in from the eyepiece. The only people currently making, well, I shouldn't say the only, there are a few people still currently making video assists. Indie Assist is one of the major ones that had one of the more polished products in terms of system integration. ARRI doesn't make the HD IVSs anymore. So slowly as they are dying, they cannot be replaced. How the video assist works. So under ordinary circumstances, you've got light coming into the eye, the lens, and it gets bounced off of, in the case, if it doesn't have a video assist, or just get bounced off of a mirror and up into the eyepiece there to the operator. In the case of a video tap, you actually use a partially silvered mirror or a pellicle beam splitter that diverts some of the light through, allows some of the light through to the video assist, and then puts the rest of it to the eyepiece so the operator can see it. Now, as the video cameras have gotten a lot more sensitive, usually it's only 20% of the light is needed to go to the video assist to still get an acceptable image. Generally speaking, the less light you have going to the video tap, the more noise you're going to see in the picture, because you have to apply more gain to be able to actually amplify the signal. So in cases where you're not using an eyepiece, some shows elect to stay on the tap all the time and never look through the eyepiece. They might use what's called a 100% video top, which is just a alternative viewing system block that directs 100% of the light to the video tap instead of the viewing system at all. There is no actual eyepiece on it. Then you can have a finer grained, lower noise image on the video tap. This is a view of a 416 here, with a traditional standard definition PAL tap on top of it, one of the original IVSs. Indie Assist, ARRI never made an HD tap for this camera. Indie Assist does, and I think there are at least one other manufacturer out there that has one available. The image that you are seeing, whether the operator or through the video assist, is actually of the ground glass. And that is because in order to get an accurate preview of what the lens is seeing, the imaging system, the taking lens, is designed to take a three-dimensional world and project it onto a flat surface, a film or a sensor, to make a flat image. In order to get a preview of that, if you are, and critically, your eyeball is round. It is not flat on the back. So if you do not have a ground glass in there and you just look through the eyepiece through the lens, you will see a image that is a bit distorted, but everything is in focus. You can't really preview any kind of depth of field or see what's sharp or what's not. So the ground glass is in there to give you both the ability to preview depth of field, because it's essentially a flat plane onto which the light coming from the mirror is projected while the mirror shutter is closed. So you get a preview of what the image is going to look like on the film. Onto this ground glass is typically etched some frame lines there to reflect the portion of the film that you care about as far as your imaging is concerned. If you look on this ground glass I have here, this is an ARRI Cam ground glass. The area in blue represents the overall, in this case, a 4-perf aperture. Typically, when you are shooting film, the aperture you're using in the gate is larger than the actual image area that you intend to use. And that is for reasons of both being able to reposition the image in post, also being able to, excuse me just a second, also being able to stabilize the image if there is any kind of lack of stability from frame to frame. We'll get into sort of how you test for that later, but one of the critical things with film is making sure that every frame is registered properly, and that you do, meaning that every film frame that advances in front of the aperture stops in exactly the same place, and is held absolutely still while it's exposed. If it's allowed to move while it's being exposed, it will be soft because the light isn't all focusing on the same spot. You'll get blurriness. But if it doesn't land in exactly the same spot every time, it will also give you streaks, and that can be a problem. Obviously, it's not giving you a sharp image at that point. So for purposes of correcting for slight differences in registration, if your frame isn't stopping in the same place every time, you have this sort of overscan area there. The downside to that then is that somebody that sees your picture is just going to see the overall area of the aperture and not necessarily the part that you care about. So you will have to shoot a framing chart, and I'll explain how you do that later, but you use the ground glass to sort of give the operator frame lines for aid in composing. Represented here, we have then, that's a 178 frame line called, they call it HDTV in the ARRI ground glass catalog, but that's 178 with then a 4x3 tick marks inside of it from the days when people had to preserve 4x3 for standard FTV. Critical thing, and this is more for those, the owners of film cameras, but ground glasses now are a pretty rare thing in terms of the number of people that can produce them. ARRI doesn't do it anymore. I hope he's still alive, but the gentleman by the name of Paul Berger in California, a company called Schurco, makes them. I think there's another company in Germany my colleague Manfred knows of, but they're a little bit specialized. They're specialized things and not something that you can just make on the fly. I think with digital cameras, people have gotten very used to the idea of being able to sort of make up their aspect ratios in all sorts of, you can compose it on the day essentially, and you can decide on the day of the prep what kind of aspect ratio you're going to shoot. With film cameras, it's contingent upon the ability to actually have the ground glass with the proper frame lines drawn on it. You can use a pencil and a vernier calipers and scales to, it's a little, excuse me just a second here. You're never going to get good enough with a pencil, though, to be able to accurately represent it. It is the smallest pencil lead they make is, I believe, a 0.0, I believe it's a 0.3 millimeter. And even that is far too thick to make frame lines according to what most people would prefer on a ground glass. So much better to use an actual ground glass. I have the URL up there. John Fowler kindly hosts the ARRI ground glass catalog that lists every single ground glass that ARRI ever produced. So odds are, if it's in that catalog, it's going to be easier to find. If it is one of the sort of formats that have come into use subsequently, like 2:1, 2.2:1, these aspect ratios did not exist back in the film days. So they weren't really, no ground glasses were ever produced for them. So if you're looking for that specifically, it's going to have to be something custom that was produced in the past 10 years after the sort of main series production of this stuff stopped. I mentioned before Academy versus super aperture. I'm actually going to keep going through this a little bit faster here. Allison, do we have until 1:30 or just until 1?
We can go as long as you need. So
okay,
if you go
I'll breeze
over,
through this
that's all right.
I'll go through this fairly fast then. Academy Super versus Academy. In the beginning, with 35 millimeter film, the image was using up the full area between the perforations, as shown here. Then, when they decided to add sound, they needed a place to provide. Originally, the sound was recorded on the film optically, so they added an optical soundtrack by moving over the imaging portion of the film and then putting that optical sound track along the side, just inside the perforations. This made the image a little bit smaller, but allowed you to have sound. But with the advent of digital recording technology, it was no longer necessary to have an optical soundtrack directly onto the film. Digital sound recording, as is typically done today, just relies on a synchronization track in the film, which is recorded typically outside the perforations. So it became possible to reclaim that space back for imaging area. That's what we now call the super format. So Academy aperture is 35 millimeter film flowing vertically with space for soundtrack. Super is the full width of the film between the perforations for image. You can see there in the middle, though, those two circles that represent the centers of the frames do not align. That's actually the most practicable importance of the difference between those two apertures. If you are using or if you have the camera set up improperly where you're using a super ground glass and a camera that's set up for an Academy aperture or vice versa, and you put a zoom on it, the zoom will not track as you zoom through the full range of it. It will seem to skew to one side, and that is because the viewing system is not actually centered on the same point that the aperture is. And consequently, usually also you have to recenter the lens mount, and typically also the rod mounts if you are converting a camera between super and normal. It may or may not be necessary to change the gate depending upon the type of camera it is. Most ARRI cameras are capable of going either way, but there are some other cameras out there, in particular 16 millimeter cameras. Some people did fairly crude super to normal conversions just by filing out the gate. There is an offset there, as I said. In the case of Super, Super 16, a similar type of process. Only in this case, it was the addition of, or the one set of perforations that was reclaimed as additional area for image. To add further confusion to all of this, there are different degrees of pull down you can apply to 35 millimeter film, 4-perf, 3-perf, 2-perf, and that just refers to the number of perforations that the film is being advanced by every single frame. As you can see here, so we've got 4-perf in the middle, 3-perf on the left, 2-perf on the right. You have different aspect ratios available. Uh-oh. Okay. Hold on just a second, please. Apologies. I do apologize for that. As I was saying, different perforation numbers afford you a sort of different frame size and a different frame aspect ratio that affects the size, that affects the the aspect ratio that can fit efficiently into that aperture. 4-perf kind of is the standard, the oldest one. It's a fairly squarish box. You can fit a more rectangular box into that easily enough. 2-perf is very rectangular to start with. So if you are going to be doing a less rectangular format like 178, maybe you're not taking maximum advantage of that. And each one of these is making your image area proportionally smaller, so your image gets grainier. So 4-perf is going to give you the biggest image, but if you were shooting 2:3:5 aspect ratio, for example, spherical, for spherical scope projection, you would not be using that full 4-perf area efficiently anyway. You'd be sort of having lines across here, lines across the center there. I don't know if you guys can see my cursor there. You'd only be taking a center extraction of that anyway. So if you are shooting a more rectangular format, the advantage of using a movement with a smaller number of perfs pull down is that it allows you to get more runtime out of the same amount of film because you're only advancing the film by a fewer number of perfs, essentially saving yourself money. So it's absolutely, it's 100% just a money saving measure. Use less film, still get more picture. In terms of how cameras are classified generally, you'll hear this isn't really discussed much in terms of digital cameras anymore, but the general classifications of film cameras, you have sync cameras, which are most cameras now are all going to run crystal sync, which is to say that when they are running at a given frame rate as specified on the side, it will be true to that frame rate, governed by a crystal oscillator that keeps it very precisely moving at the same speed. So even though they will maintain synchronicity from a timing standpoint, usually a sync camera is designed to be silent or quiet enough anyway that you can record sound along with it. Compare or contrast that to an MOS camera. MOS standing for, depending upon who you listen to, minus optical stripe, mit out sound. The actual origins are somewhat apocryphal. No one knows for sure, but MOS means no sound dampening. It's likely going to sound certainly louder than a sync camera, in some cases as loud as a blender, like the 435. And then on top of that, a camera, usually an MOS camera, could be classified as high speed, which usually just means it can go faster than 60 frames per second. And the term high speed is somewhat a bit more nebulous. It falls in different places depending upon who you're talking to. Some people would say anything over 48 frames is high speed. It varies, but there are dedicated high speed cameras like Photosonics that can go up to hundreds or thousands of frames per second. That are definitely dedicated high speed, but are not something you can use for sound recording because they are extremely loud. As far as what ARRI offers currently in sort of the current gen of cameras, though obviously as film production has sort of receded into time, there's been a lot more people have just been buying up older film cameras and making them work. A lot of them still work perfectly fine now, 40, 50 years later. The sort of premier cameras right now are, to our mind, unsurpassed. The ARRI Cam LT and ST, both sync cameras, the LT being a lightweight version, the ST being a studio version, very quiet. You have the 416 and 16 millimeter. There's also the 235 and the 435, which are MOS cameras. 435 able to go up to 150 frames per second, pin registered. So it's a very steady image, but can go at very high speeds. 235 is very small, lightweight, can fit into a lot of places. I'm going to quickly breeze through this stuff because we're already over an hour here, but a few things you need to worry about with film cameras that in this case, you do actually have to worry about this with digital cameras, but you have to check it slightly different with a film camera. For those of you familiar with the idea of collimation, lens collimation, making sure that the flange depth on the camera lines up properly such that the lens will hit its marks when focused on the camera. So here we have a mount, and I am seeing is somebody speaking in the background there? Would it be possible to mute whoever that is? Thank you. All right, so here's a mount. This is obviously an LPL mount, and no film camera is available with an LPL mount. LPL mounts are in fact incompatible with film cameras because of their short flange depth. Never mind that, just for illustration purposes. So when we're talking about flange depth, we're talking about the distance between this front surface of the mount, they call that the flange, down to wherever the imager would ordinarily sit. That distance in depth is critical and is generally defined by the mount standard. In the case of LPL, it's 44 millimeters. In the case of PL, it's 52 millimeters. And that is essential because in order for the lens to hit its marks accurately, that distance must be held fairly precisely. That's sort of like how they design the lens to project its image a certain distance behind the front back surface of the mount on the lens. That's essential to make sure the lens focuses up properly. So if you have everything lined up properly, so let's say that's our flange surface and we've got our sensor there again, reusing some of these slides from the digital presentation, so don't mind that it's a Alexa Mini there, but you got the lens that fits in there, presses up against the flange. We're talking about the flange focal distance there going from the flange. When everything's aligned properly, the lens is projecting an image onto the image plane properly. If the flange is either too short or too long, the image will be projected either behind or in front of the sensor plane or film plane in this case, and then your image will not be sharp, or rather the actual focusing place on the lens, point of principal focus, will not line up with the marks on the side. In the case of a digital camera, you're typically assessing this with a collimator on the side, or something like a DENS, which is essentially a miniature auto collimator. In the case of a film camera, though, you have to measure this two ways. To the ground glass to ensure that you have an adequate depth of field representation or adequate focus representation, you do need to use a collimator because there's no way to mechanically measure the distance from the flange to the ground glass because the ground glass is actually up at an angle. But in the case of the film plane, you measure it with a gauge, as a micrometer gauge as shown here. Usually you buy it as a set. It comes with a little dial gauge, a depth standard that is measured to very precisely and fabricated to a very precise depth standard for that mount type. In this case, typically PL. And then you have a little highly polished plate that's very smooth. The idea is you essentially tear the dial gauge out against 52 millimeter depth standard and then press it into the gate of the film, or press that into the mount of the film camera with the shutter swung out of the way, of course, so you don't shatter it. You then take a little metal plate, surface plate, put that into the gate where the film would be, and then you are pressing the micrometer against the flange on the front and against the plate on the back. That distance should be held to 52 millimeters if a PL camera, plus a slight tolerance depending upon the camera, to actually reflect the fact that you don't, if you were focusing the light at exactly 52 millimeters, you'd be focusing it on the surface of the film, but the film does itself have a little bit of thickness. So in practice, you actually want the distance to be slightly less, typically between 51.97 and 50, well, yeah, between 51.97 and 51.98 millimeters is the standard for most modern ARRI cameras. And that's just to account for the fact that you want the image actually focused in the middle of the thickness of the film, not on the front surface. Other thing you have to do with film cameras, you have to scratch them. I'm not going to go through this you could talk to somebody about how to do a film scratch test, but the essential of it is you need to run film through the camera with every single magazine you have, and every single body you have, to make sure that at no place is there scratches happening on the film. A scratch film, because that's your only recording medium. If the film gets scratched, and it can happen if you have a piece of debris get in the gate, if the gate gets scratched itself, and there's a raised portion of the metal, that can cause scratching. It is the advantage is it's all a mechanical process. So if something's scratching, it's because there's a piece of debris somewhere. It's not like it's a bug in code somewhere that you need to have a computer science degree to find. There's a piece of dust in there somewhere. So you just need to tear the camera apart far enough to actually get to it and clean it. But absolutely necessary to check every magazine and every camera body with fresh virgin film. And then you just inspect the emulsion under a bright light and see if there are any scratches. If there aren't, they're good. If there is, then you need to work on either magazine, clean out the throat, and or refer it to the service department, and they can then address that. The last thing would be a steadiness test. As I mentioned earlier, essential to the proper operation of a film camera is making sure that every single frame is stopped in exactly the same place behind the aperture. So the way we test that is actually by doing a double exposure, which is another thing you can do on film that you can't do on digital. You run the film past, you put up a grid pattern similar to this in front of the camera, making sure that the camera is held very still and steady, and to the extent that you actually don't even want to run the camera with the button on the side of it. Usually you want to use a remote switch to trigger it so you don't introduce any vibration whatsoever. So you will run the camera a certain number of feet, photographing a grid pattern like this, normally illuminated and metered as you would, and then rewind the film in complete darkness and take a second exposure with the same grid pattern rotated some arbitrary distance between 0 and 90 degrees. Obviously, you don't want to rotate it a full 90 degrees or it'll just be lined up again. But the goal is that when you then view the double exposure image, you have a overlay of the grid pattern such that they are not orthogonal to each other. You have sort of these converging and diverging lines, so that if there is any discrepancy, if the frames are landing in exactly the same place on both exposures, you won't see any change in the positioning of those two exposures relative to each other. If there is any discrepancy between the two of those, they will sort of vibrate against each other. And you can sort of see the relationship between those lines changing. I have a illustration here. So this is a steady test. Play this for you briefly. It's a little hard to see, but if you look sort of particularly toward the bottom of this frame, you can see some of the lines there at the bottom are sort of, you can sort of see them wobbling, and so the distance between them is changing. That reflects that this camera is unsteady. The frames are not actually landing in exactly the same place every time. Contrast that to a passing test. Playing this one back now. Now they are stable relative to each other. Now you may notice that there is, if you're looking at the periphery of these of this image, that there is a little bit of bob and weave to the image. That's actually okay. How I can tell this is not the camera? If it was the camera, there would be a difference between the lines there. A frequent source of confusion over this, people who are not used to looking at these may see that little bit of bob and weave and say, oh, there's a problem with the camera. Well, no, in this case, the problem is more than likely with the scanner that was digitizing this film to make this video image that I'm playing back for you now. Depending upon the type of scanner it was, if it was a telecine machine, which is designed to run continuously, it's like they may or may not have pin registration for each film. So the telecine, depending upon whether it has a flying window or not, may or may not include image stabilization technology in it. If it's an older telecine, it may be unsteady. So that isn't inherently a problem. There are ways you can fix that in post, but in this case, the fact that there is that bob and weave doesn't mean it's a problem with the camera. If it was a problem with the camera, you'd see it between the lines, not at the edges of the frame. And finally, I mentioned earlier, when you have it with film, there is no way to know what the intended aspect ratio was. There isn't really much in the way of metadata with film that we've gotten so used to with digital. You can append all of this information. So now when you get your frame out of the camera, it tells you, oh, and by the way, we were using 178 frame lines on this. And when they punch it up in post, they can just see all of that. Well, on film, there is literally nothing that links the image on the actual film itself to what the operator saw looking through the ground glass. For that reason, you have to shoot a frame leader chart like this one, which corresponds, you line it up with the lines on your ground glass like this, and photograph that. That then gets appended to the header of every single roll when they then go to do the telecine for it, so that the editor can properly mat the frame. Because again, there's nothing, unless you are using a hard mat in the gate, which would be effectively changing the aperture so that nothing other than the area you care about is recorded. That's one way to avoid having to do this, I guess, but it comes at a cost of, if you got any dust or hairs in the edges of that aperture, you're going to see them and your shot is ruined. So it also leaves you no room to be able to do any kind of image stabilization afterwards or backing out. So most people prefer to shoot with an open gate. For those of you who wonder where that term open gate came from, now used in Alexa's digital cameras, it's from the concept of using the full aperture of an area available without matting down to a smaller recording format. But that's why you absolutely have to shoot a frame leader. That's what I have. Apologize if that was a lot. Does anyone have any questions?
You can throw questions in the chat, and if you don't want to say them out loud.
So you can't, so what tools and chemicals are needed to clean the sensor on a film camera? So on a film camera, you would never clean, the sensor is the film, so you would never be cleaning the film. Generally speaking, you need to keep the film dust-free and dry. It arrives that way from Kodak, and you kind of just need to make sure you keep it clean when you're loading it. As far as cleaning the actual mechanical surfaces, generally I like to use isopropyl alcohol, high purity isopropyl alcohol, that will clean. It's all stainless steel inside, usually most of the surfaces. It's rare that you have to actually use liquid cleaning, though. The only places where you might need to use that is around the lens mount, which is no different than you would on a digital camera. Just that can get a bit grody over time. So you would want to use some kind of cleaning material, but usually any kind of highly volatile solvent like that would be fine. I wouldn't use water because it is steel, and if it gets wet, it can rust eventually. But alcohol is fine. Question: and talking about scanners, you mentioned flying window. Something similar. What is that? That is essentially some film scanners have technology that essentially recognize, it's sort of like an early version of AI, you could say, where it actually looks at, it's imaging a larger area than the actual each film frame, and has software that recognizes where the image starts and ends. So it actually sort of photographs a larger area and then either digitally crops in on the area that is the film itself. In the older case, sometimes it actually was a physically moving turret that had the imager on it that was scanning the film, that would adjust itself automatically as the film flew through, depending upon if the film wasn't perfectly aligned properly. So that's scanning technology. Depending upon the vintage of the scanner, it essentially does the scanner correct for any bob and weave in the film as it's flowing past the scan port, or does it not? Some do, some don't. That technology is difficult to implement in real time and tends to be only found in the more expensive telecines and scanners out there. Any other questions? Okay. Well, thank you all for coming. One final concluding thought I would offer. Obviously, I threw a lot of information at you here. One thing about film, it really is something. The only way you can learn about it is by getting your hands on it. It really is a tactile medium. A lot of the nuances of working with film are things about learning how something is supposed to sound, learning how something is supposed to feel, learning how much vibration is normal. Some of those very analog, tactile things, there's no way to really easily quantify what is right. You just kind of need to get a feel for it. So by all means, if you're interested in learning film, it is, it's growing again. We are seeing, certainly here at ARRI Rental, a great increase in interest in film cameras. Our 416s in particular continue to be busy all the time. And Kodak is seeing growth as well. So, and it is something that it's a skill set that is now somewhat undersupplied in the marketplace. There are people out there that want to shoot film that are having difficulty doing so because they can't get crew that know how to do it properly. So it is certainly a skill set that commands a premium now in the marketplace as a camera assistant. Film loaders are able to get paid a premium over digital loaders because of the rarity of that skill. So it is something that can be potentially lucrative to study as well. All right.
All right.
Allison, Harry, any closing words?
Just want to thank everybody for coming, and we will have this recording up and available soon. We'll make sure people get that link. And so thank you for joining today, and thank you, Mike, for that deep and in-depth knowledge of film and film cameras. It was great. I also learned on film, so I certainly very much appreciated it. So thank you so much. Thank you everybody for coming, and we'll see you on the next one.